Forces, question 2b. Okay, so the first thing I'm going to do is I'm going to cub this question. So the question is about speed. Okay, figure 1 shows distance time graph. Yeah, explain. Okay, what figure 1 shows about the motion of the car between points A and E. You should use values. So I've got to use values. It's the motion of the car between point A and point E. I've got to use values there. I've got distance time graph. There's point A, point E, and it's worth 4 marks, which means in total I'm going to have to put at least 4 bullet points. So 1, 2, 3, 4. So I'm looking to say 4 things about this graph here, and I need to use values. Whenever I see use values, that means I've got to draw on the figure, and I've got to use numbers from it. So got to say 4 things. So 1, 2, 3. There's 4. There's 4 bits to this graph. So I'm going to say something about each bit. So first thing I'm going to do is section it up by drawing on it like this. It makes it easier for me to make sure that I include values and demonstrate that I've used the graph. Okay, there we go. And then I'm going to start saying bits about it. So from A to B, what happens? Car travels how far? From 0 to 250 meters in 20 seconds. 20 seconds. I could work out, therefore, the speed. What else can I say about that, though? I know this is a straight line. Whenever I see straight line, I know it's the word constant. Okay? It travels at constant. And then, if I'm not sure, I know here, because it's distance time graph, that's as constant speed. Okay, whenever we see a graph, we always think about the steepness. Always remember the steepness. So that's a constant steepness. Steepness equals rate as well. Now, the rate of change of distance in time is a special case. It's called speed. So it travels at constant speed. And that speed is equal to 250 meters divided by 20. So 250 divided by 20 equals, what does that equal? Just check, do it on my calculator, make sure I get it right. Divided by 20 is equal to 12.5 meters per second. Okay, and that's a really strong answer for the first part. Now what I don't want to do is sort of forget about the rest. I have to answer the rest as well. So from B to C, car stays at 250 meters for 20 seconds. Okay, so it doesn't move. Doesn't move. Another word for that is stationary. Okay, so it doesn't move. Then from C to D, car travels. You'll notice here I'm trying to use the same sort of language each time because it works, so I'm not going to change it. So car travels from 250 meters, 250 to 500 meters in another 20 seconds. 20 seconds. It travels at constant speed because it's a straight line, constant steepness. It travels at constant speed of distance over time again, so it's 250 to 500 total, so it moves 250 meters, takes 20 seconds, equal 12.5 meters per second. And I can see that just by inspection. I know that the steepness of that line there is the same as the steepness of that line there. So the last one, from D to E, car travels, and this is where it's going backwards. So it travels from 500, so back from, I can't spell today, from 500 to 0 meters in 30 seconds. So I'm using as much data as I can to make sure that I'm definitely going to get the credit, get the mark for this. And it does that. It travels at constant speed. Constant speed of, and the constant speed now is, so it travels a total of 500 meters, or 500 meters, distance divided by time, so 500 meters divided by time, it's 500 divided by 30, which is a total of 16.7 meters per second. Now it actually comes out as 16.6, sorry, I'll hidden off the bottom, 16.6 reoccurring, except we remember in science we never use that dot. Okay, we always round it to decimal point or single figures. Okay, so we wouldn't get the mark necessary for that. Now that's a really strong, I mean that would probably be a 6 mark answer there if it was a 6 mark question, but that's a really solid 4 marks.